this kind of light beam, right? Like saying so that this is something is important. Want to have more realistic kind of video game professional video game player, so that they want to have a much better experience, right? Have additional this kind of thing.
Awaken your inner Jedi.
So this particular one, you can see you have not, I think it's AR, you say, so that you try to look at some this kind of virtual, this kind of maybe your enemy, and then with this kind of this one, you try to fight with this virtual enemy, right? Do you understand? So that's something is there's some more interaction, right? With VR, so that only you can see, right? You have no interaction, right? So that I think this is something augmentation with additional this kind of thing will be quite interesting for professional gaming. I do believe this is has a huge application in this kind of gaming industry for sure. There's no doubt at all, right? So that this is something is quite again, so that you can see that this is I do think it's interesting for all of you. And of course, as I mentioned, that this kind of VR, AR, MR has a lot more. Why? At least in short term, for sure, gaming is a big business, right? And then you have some other thing, virtual tourism, social networking, and this kind of even for building, for sure. That's for example, this company, Kellogg Studio, they do have this kind of VR system for this kind of building engineering, architecture, engineering, construction, doing that. And of course, we can think about this thing, right? If you try to borrow my this kind of Facebook, this kind of VR headset, so that I don't know if you watch this kind of Facebook CEO the talk, so that there's some special way, so that three-dimensional social networking through the VR headset. Doing that, Facebook is a 2D, but once you have the VR, AR headset, and then so that that will be quite important business from Facebook CEO point of view. Right? Of course, now they change the name, Meta, right? Metaverse. Okay, so that this is something will be quite important. Anyway, so that this involve, as I mentioned, it is involve a series of technology from advanced the GPU for display, 3D display, advanced maybe additional AI processor and sensor and advanced display and optics. So it's a quite sophisticated this kind of integration about all the advanced this kind of component. Right? You see the sensor, right? And actuator, room tracker, and some LAN display. So that's quite important to see, right? So it's require a lot more this kind of integration about advanced this kind of technology, especially in semiconductor. Okay, haptic, right? So that's it. Oh, AAC. Anyone you know this AAC? AAC is a public company in Hong Kong, and the headquarters in Shenzhen. They are expert to make this kind of smartphone mains microphone, and also this kind of speaker for our iPhone. So that is one of top three maker of this kind of smartphone, this kind of mains microphone and loudspeaker. So that so of course this is also important for not only this kind of smartphone but VR, AR, MR. So that I said that you know that in Hong Kong, there's one big Hong Kong public company. Okay, so that the founder used to sell some electronic component in Shenzhen. I don't know, probably you heard about this kind of Huaqiang in Shenzhen. It's very big this kind of no, there's so many companies sell this kind of electronic component, right? So the founder actually used to sell some small electronic component and then gradually think about to make this kind of loudspeaker for smartphone and then bigger until they become a public company, right? And then it's top 3 in the world, okay, for this kind of MEMS microphone. So that tell you it's important. So anything related to this kind of smartphone business will be huge, huge business. Okay, yeah. And anyway, so that last time we also quick. I think we will not repeat thing, but the key thing here is you want to have VR, AR, all this kind of system. So what's the more important thing? How you let the user to experience this kind of immersive, this kind of experience, right? Compared with smartphone or computer, this is your the whole body immerse this kind of now realistic, now virtual like environment, right? And then with this kind of visual and audio effect, right? And of course, another additional major touch sensation. And in the near future, maybe we have using semiconductor, this kind of sensor to create this kind of artificial, this kind of the sensation. There's a human and 5 senses. I do believe this gradually all this will be engineer will create all this kind of human sensation, so that become more and more complete set of this kind of virtual reality, this kind of experience, right? So that I think at this moment, most likely we have a very good simple image sensor, right? And microphone, and we also have. Well, I'll show you why. This one, haptic, tactile sensation sensor, right? So, but for this two, it's very difficult. But I believe in near future, if you are able to make this kind of low cost, high perform, this kind of sensor for VR, AR, you'll be super rich. Did you agree? Huh? What do you think? So do you say? So for this one, how big? You know, we have every smartphone. We have this kind of a simple image sensor, right? Huh? So that it's one of the biggest market CIS in for all among all the sensor. So that and then microphone, I told you, AAC become public company. So that what do you think? All this can create at least $1 billion business. There's no doubt at all, right? But it's difficult for this two, the last two. Okay, so that so I said let you know this is difficult, but once you make it, and then definitely it's waiting for a young student and young engineer to implement this tool. This tool is something difficult, but I'm pretty sure that will be quite important. Okay. Of course, for VR AR, then we most likely will not only happy about this kind of a conventional camera, simple image sensor. So how can we have 3D this kind of camera? What do you think? I think there's another trend. In order to have this kind of immersive like experience for VR, AR, MR, so that for sure this kind of thing we will enter into this kind of thing. One student asked about the difficulty in create sense of microgravity. Kevin, I agree. Microgravity is not easy. But as I showed you last time, there's one company, Switzerland company, right? We still can make something VR experiment flying like bird. I do still remember about last time we show you that the video about flying like bird, huh? Yes, it's not easy to do this kind of microgravity, but still flying, make this kind of VR system flying like bird have been done, huh? have been done. But I hope you still remember. But of course, try to mimic this kind of falling, and then that's an answer. That's difficult. That's difficult. But flying like bird is have been implemented. We show you last time, and then so I believe maybe the company also have one branch in Hong Kong. You can also try flying like bird. So that this is something. I just show here. You see, this is something. Although I agree with Kevin, so that how to mimic this kind of environment about microgravity is non-trivial. Okay, it's non-trivial. But of course, this kind of Facebook VR has an International Space Station app. So actually, you can experience this kind of experience in the space station. So that that's why I told you that I surprised nobody liked to give a try about that VR for this kind of ISS. It's quite good experience. This is a free this kind of it's free with I download. Let me quickly show you this one. Personally, I asked any of you interesting surprise. Yeah, this is the one actually I download in my Facebook VR headset. That means if you wear this one, you can really, although it's difficult for you physically go to International Space Station, but at least in the Facebook VR headset I've been using, is quite interesting.
Welcome to the ISS in virtual reality. We are coming up on the
You can really try to play
space station.
Some of a component of something machine inside this space station.
And coming underneath the docking port and grabbing a hold.
It's quite interesting.
And this is the bottom of the station. And this is the most forward section, and we are moving aft. The Oculus Rift has a free program, Mission ISS, and that's what we're looking at. It is a wonderful program. It is not a game. It's not a shoot 'em up. You don't experience points or anything like that. There are a few missions you can do.
Oh,
two of them are really
easy,
and
experience.
One is very, very challenging.
I believe none of you have a chance to go to space.
Spacecraft, and it's a lot of fun.
Try the VR, this kind of,
but I would imagine that most people would enjoy this experience immensely, but probably wouldn't think much of it after they've experienced it once. But for those of you who are dreaming about space and even becoming an astronaut, you're going to love this and probably spend a lot of time. This is the very first space vehicle to go, the Zarya, and that was the first one to go into space, to build the space station. Then the Zvezda came along a couple missions after that. They did the Russian Zarya first, and then the Unity module, and then which is Node 1, and then this Zvezda.
Well, I do recommend
Let's grab a hold of the station.
Any of you like to give a try? I'm surprised that none of you like to play this kind of thing. It's free. Okay. Anyway, so Kevin, do you want to try? Although we cannot experience this kind of microgravity, but at least you can experience this kind of using Facebook, this kind of VR, so that oh, okay, no problem. We can find some special time, and then you come to like our MAE conference room, and then so that next to my office, then so that no problem, it's free. It's free for you to try. Okay, good. We have one student I really want to give a try. Although again, it's difficult to play some microgravity, but I think this is something. Oh wow, one more student likes to try. Anyway, free. Okay, it's a free. I will not charge you. It's free. So see, free for all of you like to experience for this kind of course, that is instead of the watch this kind of lecture note, look at the lecture note, but you give it a try. I do think it's very, very good experience. And then so that, of course, you may also look at the additional app, right? So look at the kind of a build design, right? Actually, I also have this kind of app download from my Facebook VR, how you design the kind of thing, so that it's not only for fun, but it's have a real engineering app for the thing, okay? Anyway, I secondly part it is, the most important thing I hope all of you understand is human sensation is very, very precise, sophisticated, so that at this moment our human technology still not easy to really achieve this kind of good, this kind of visual and audio, all things, so that at least I show the key thing here as the bottom line is here. We are still at least you can see. Look at this thing, right? About 2000 by 1000. This one compared with this kind of human eye resolution, still with older magnitude, this kind of a difference. So that is important for all of you to understand. You see, in terms of this kind of pixel per inch, you see, still older magnitude difference. So that the engineer still need to work very hard to push to become more this kind of more realistic, right? This kind of 3D, this kind of virtual immersive experience. That is something I need to let all of you understand. So that of course, when who can try to push this kind of system to this one, then can make a big money. That's something I just told you. This is not easy, but and of course I also mentioned one of my UCLA lab mate has a company, LuxView, right, for this kind of a micro LED, right, and they acquired by Apple. So that's to try to gradually to see if possible we can increase, right? Do you say at this moment the dominant? What's the dominant this kind of display technology in your smartphone? Huh? I also ask you what is the mainstream? Huh? Mainstream this kind of display technology in your smartphone? Huh? Any idea? I believe all of you have smartphone. What kind of display? Huh? What kind of display do you have in your smartphone? Huh? Nobody know? Oh, very good. We have yes, you are right. OLED, organic LED, is the mainstream this kind of technology in your smartphone. We're lucky like with Professor Chin Tan in our USTIS is who he invented this kind of organic LED. One student mentioned liquid crystal. Paul Yan mentioned the liquid crystal. It's low end. Liquid crystal display LCD. It's low end. It's low end display. It's still used, but for smartphone, that the quality is not good enough. Low end. I believe none of your smartphone using LCD because performance-wise, it's not good and consume too much power. Okay, so that is the problem why people will use this kind of organic LED. Why? Of course, again, OLED organic LED still not good enough for advanced VR AR like here, right? So next generation of this kind of technology for VR AR MR is not most likely is micro LED. It's something it's micro LED technology. So this is something I tell you why. So that from OLED to this one, so that there's a lot of company put huge $1 billion in this micro LED. So that's something again. One of my Edward, okay, one of my UCLA lab mate has a company, okay, LuxView, and acquired by Apple 7 years ago, right? So that suddenly become super rich. Okay, so I tell you this is something. Whenever you think about this kind of thing, then you think there's a behind. Some engineer can come with a good solution and then can become super rich. That's something I just showed you. Yeah. And of course, another thing is our ear, human, this kind of ear has also very sensitive, this kind of this, and in terms of frequency range, right? 20 to about 20 kilohertz. So that is typical thing. I just from 20 to 20 kilohertz. This is a typical humans, this kind of frequency response of human ear, right? And then of course our ear can also have very high dynamic range. You can see high dynamic range to look at the very whispering sound to very noisy sound, right? dB is decimal bell, right? Typical for this kind of the sound, this kind of the output, right? So that you can see its range is huge actually. The dynamic range to measure this kind of sound, our human ear is excellent, I would say. You can see it can from here to here. That is quite I would say quite amazing. 80 dB. So do you know how good is this one? Human sensation is excellent. 80 dB, that means if divided by 20, why it's 4. So most likely it's 10 to the power 4. That means a very thing to it's a 4 order magnitude, right? In terms of this kind of sound, this kind of intensity, do you say? So this is 10,000. This is quite amazing. I told you, human sensation is really amazing. Okay, and of course, some location is another sign. Why human or many animals have 2 ears? Why? What's the reason? Okay, through the natural evolution, if you have 1 ear, maybe some animal will die. You need to try to hear or 2 eye to spot all the enemy, right? In this kind of evolution, so that if some animal like human have only 1 eye, 1 ear, and then most likely it's very difficult to survive when you have so many enemies. So that once you have this sound localization, right? That means 2 eye and 2 ears, so that we can really try to detect all the animal want to kill. So that this is something is important. Of course, same thing. If we want to have very good experience, right, in VR, AR, MR systems, so that it's important we need to generate this kind of good 3-dimensional sound field, experience, and then our microphone, right? In the VR, AR, MR, so they have to have pick up the thing, right? So this is something quite important, yeah. And of course, I think I also tell you that we are not only look at this kind of sound localization, we also need to have what? How can we generate very good this kind of 3D, this kind of sound field with not only one loudspeaker, maybe a loudspeaker array, right? So this is something is important for VR, AR, MR. So that I just tell you that it happened. I know the CTO of X-Men, right? So who is the company is in Silicon Valley, so that they really make excellent. They say one of the first this kind of smallest segments loudspeaker for VR, AR, MR system. So that I happen to know the CTO is actually my friend. So that let me quickly show you this is also quite important for VR, AR. Not only for, you see, how we can have a, you want the 3D sound. You need to have not only one loudspeaker. You can try. So this, they really make this kind of excellent. Loudspeaker array, micro loudspeaker array. Shock resistant. Oh, so that the CTO actually is my friend. So that I do believe this is very important for this kind of VR, AR, MR, so that you need a 3D, three-dimensional sensation, three-dimensional sound field, three-dimensional this kind of display. Do you understand? So anything relation can make this kind of big money. No, it's no doubt at all. Okay, so that again, this is this X-Men is a first company. People claim that he can really make this kind of 3D kind of micro speaker array using piezoelectric material. Okay, so that I tell you this is something is quite important for all of you to think about this. Okay, and of course, last time we'll show you touch. Why? In order to have this kind of virtual reality, more realistic experience, so that the touch is important, and then of course it's also non-trivial. So that how can we first understand about human kind of sensation, tactile sensation, so that I still remember last year, this Nobel Prize go for that's about 2 or 3 professors or something really try to understand about this kind of a mechanical transduction principle for this kind of sensation. I don't know if you remember last year there's a Nobel Prize go actually for the one who really understand molecular understanding mechanism of how this kind of a mechanical transduction for this kind of touch sensing. It's very complicated thing, but and then of course for engineer, we are trying to make this kind of real, this kind of product for this kind of haptic sensation. And again, so that there's a let me quickly show you this thing. We already talked about this thing. I think we don't need it, but the key thing we should go to this particular. Again, we also mentioned about there's a series of this kind of VR, AR, this kind of product, so that it's clear that there's a between low end to high end. So there's a large family of this kind of difference, right? So that I just told you this is something I remember last year. Gradually, I think the company make a better and better product, right? And so that if you look, you have experience about low end, Google this kind of this one, then you try to look at those kind of high end, then you see, I think the price can determine the performance a lot in this kind of VR AR headset. So that's something I tell you is you do I do recommend you really try some of this kind of thing. Okay, so that hey, I try to give you additional information about the difference. Right? You say for this kind of Oculus Rift is first generation. Why? And then acquired by Facebook, who mentioned in the first slide, and then second generation, you can see the price become almost $400 US. Why? It's about more than $3,000. Why? And then you look at the inside, you need have so many this kind of organic LED, why special lens and MEMS motion sensor IMU. We should show you. IMU basically is what we mentioned in previous slide. So what's IMU? It's an inertial measurement unit. We mentioned, why it usually consists of this kind of micro sensor, accelerometer, and also the gyro. Right, so this is a typical thing. Right, of course, sometimes you have a three axes, major X, Y, Z, three axes, and then the sensing here also three axes. So in this case, we have both sides is a 6 degree of freedom. 6 degree of freedom, this IMU, means IMU. Okay, so that's typical thing. And of course, typically, so that's why in here. Because we have a major, this kind of acceleration, right, in X, Y, and Z direction. Remember this, the three direction, and then measure this kind of angular velocity, rotation, right? Rotation in these three, rotate this one here and here, right? So that in this case, we have a 1, 2, 3, 4, 5, 6, total 6, okay? And then, so of course, that is a typical thing I still show you here. And again, so that you see, we do have this kind of 6 degree freedom motion sensor. And then this kind of micromagnetic sensor. Sometimes they're called digital compass, right? And proximity sensor. So this is something becomes so common now. And again, your smartphone at all have a proximity sensor. So I don't know, do you know why every smartphone needs kind of thing? What's the application of this proximity sensor? Any idea? What? Huh? So I want to know, do you have an idea why every smartphone now have why every smartphone we have this kind of proximity sensor? Do you have any idea, or even sensor? Very good. One student say detect environmental light intensity. Why you want to detect light intensity? Typically, in your smartphone or this VR headset, proximity sensor has two typical functions for your smartphone proximity. One, it can measure light intensity. Second one, it can measure this kind of distance. Okay, they have you seen some VCL, solid state laser. Okay, so proximity sensor typically, I would say, typically in your smartphone, typically include to measure this kind of distance and light intensity. That's okay. Distance. Why we need a distance? Because distance means that we want this kind of smartphone be smart enough to detect our user this kind of status. If you are trying to look at your smartphone and then that the laser infrared, this kind of light source and laser will try to detect, okay, you are close to your smartphone, right? And then it can adjust a light intensity of the display of your smartphone. Do you understand? So that's something, if you try to, okay, I put your smartphone on the desk, and then in this case, then smartphone will what happened to smartphone? In order to reduce this kind of power consumption, they will try to maybe turn off this kind of display to save power. So that's typical, thing for to save power. One student say is LiDAR a kind of proximity sensor? This is a very good question. Proximity sensor typically is only provide 1 degree, one pixel, 1 unit of this kind of thing to detect this kind of thing. Do you understand? But LiDAR typically they try to detect, do some most likely scanning, 3-dimensional this kind of thing. So do you understand? So that I would say LiDAR, at least they want to LiDAR is also quite important. Okay, it's most likely is provide this kind of 3D this kind of scanning, right? Scanning of this kind of thing, but the proximity sensor only try to look at or have one unit of this kind of a sensor to measure this kind of distance and light intensity only. So it's still a difference. And I think all of you probably heard about the new this kind of iPad. Apple iPad has the MEMS LiDAR, right? So that that actually is something become, because they use this kind of semiconductor to make this one, so it can be much cheaper. Even I think iPhone 10, like my iPhone 10 has some kind of this kind of array of this kind of laser. For what? Facial recognition. Oh, so that you actually iPhone 10 has this kind of I would say now this kind of array of this kind of laser, B cell laser. Okay, so about 300 for facial, and then infrared this kind of sensor array, right? So that for facial recognition. Okay, so that's something it's quite important for all of you understand, right? Your smartphone has much more sophisticated this kind of thing, and then for facial identification. Yeah, one student White mentioned, you're right. So that of course this kind of array of sensor and array of the laser has of course can be used for this kind of LiDAR application. There's no doubt, and of course it really depends on those kind of power consumption and how much power for this kind of solid state laser VCL, right? So that depends on, for example, for self-driving car, they have much high power, so that they can try to look at those kind of long distance, right? So this is something I just tell you. Let me look at actually next to Hong Kong, RoboSense has this kind of RoboSense. I don't know. Actually, I know he will try to go to IPO in Hong Kong stock market. So that it is like one student asked about this kind of LiDAR. So let me just show you about this kind of RoboSense. So this company will go to IPO in Hong Kong stock market soon. Okay, so that that means proximity sensor only measure 1 point, right? Look at our smartphone thing, but here is to scanning, scan 3-dimensional. This kind of environment for self-driving car is important. Definitely, this can be also useful for our VR AR system. So inside this kind of a product, so that the MEMS is critical, make it more compact, much cheaper. So that I don't know if you have ever seen that kind of one still asks, how can this kind of a MEMS LiDAR to compute? I want Kevin asked the question, how can this kind of LiDAR try to do calculation about this kind of thing? So of course once it's 3D scanning, right? So you have quite a lot more data of this kind of now 3D, this kind of sensing. So in this case, they must have very sophisticated data processing to process this kind of data from this MEMS LiDAR for self-driving cars. So that's why it require also most likely in the near future, all this kind of self-driving car need to have what high speed, this kind of AI GPU to process this kind of data. So this is quite important. So I don't know if this student Kevin want to what kind of question you say, how how they process data or how to do calculation? I don't know your question. So of course you can know. In general, once you have 3D sensing, and then you acquire a lot more, for sure. Yes, once you have 3D is kind of a sensing, like now in this case, for sure, you will a lot more data collect from this kind of sensor, so that you need a very advanced semiconductor, this kind of a chip, right? The processor and even GPU and some maybe additional AI edge computing to processing wise for this kind of self-driving car. There's no doubt at all. So this is require advanced technology. So this is something, it's non-trivial, but because self-driving car is quite important technology. So I do believe that all the big company invest a lot, at least $1 billion to make this kind of advanced, this kind of system. Why? So that okay, anyway, so that another this VR headset is HTC. In particular, this actually has you see about more than 70 sensor. Okay, so that main gyroscope and accelerometer motion similar to the previous Facebook VR, right? And laser position sensor, right? So that in this case, you have to be really much more professional. And definitely this is quite expensive. HTC, this kind of HTC Vive Pro is quite expensive. Okay, so that why expensive? Unless you have so many sensor data, you need to have advanced this GPU and all these things. You see, they use NVIDIA, now they can GPU or AMD to process real-time data of all the sensor. Right, and then try to also try to generate 3D display. So, and then of course, once you have so much data, then what's the problem? All this consume much more power. So it's non-trivial to have this kind of wearable VR, AR, and MR headset with low power. Once you're very, very good, this kind of system, you need a lot more this kind of sensor, a lot more 3D display, right? And also even you see this mains microphone array, and then high speed, this kind of a processor, GPU, and then so that you consume a lot more power. So it's a non-trivial. This kind of require advanced engineer, put a lot of money to improve the performance, right? Yeah, and then of course one more question is the battery. Once you consume so much power, very complicated things, and then how can we have a battery to be practical and last a long time? So it's very difficult to make a high performance and wearable VR, AR, MR system. But anyway, so here I show you at this moment you can find a series of this kind of VR system, and so from many big companies, they really think this is quite important for what? For next generation of computing device, right? Beyond smartphone. If you look at the Facebook CEO and founder, and then he really clear to mention that why he put this kind of $2 billion for Oculus, this start company, because he think for him, it's important, right? He has to go to this kind of VR for this metaverse, right? So it's a quite important next generation of social network platform beyond typical Facebook you are using now, right? Again, so that of course there's another family of this kind of AR system, smart glass, right? And this kind of Microsoft had HoloLens and Magic Leap, why this is something become also quite important. Why? Of course, now we have a HoloLens 2. Now, especially in COVID-19, it turns out this is very important. So why is it important? In the COVID-19, what's the problem? How we can use this kind of AR system, why this is important? I want to ask you why HoloLens become so important for COVID-19. Any idea? Any idea why this kind of VR AR is so important in the COVID-19? Well, it's important for all of you to. One student say, virtual 3D learning. Is well, if we can have this kind of 3D, this kind of Zoom meeting for online teaching, that's great, right? And also, I think from industry point of view, especially from big company, if if they want to send engineer overseas for international travel to business trip, or engineer who send from one country to another country, it's so difficult. So if how about if you use HoloLens too? The engineer don't have to fly from maybe US, from Europe to maybe another country. So use this VR AR headset so that to do remote this kind of support for maybe installation of the machine or something. So it's actually now due to COVID-19, it turns out this kind of thing is critical, all right, to solve the problem. For a lot of, actually, I haven't go back to my hometown for more than 2 years, so that this is really difficult. But how can we use this kind of for this kind of in the COVID-19 for this kind of remote assist? Let me say remote assist. Let me show you this kind of video, then you see why this is important to solve the problem of COVID-19. Okay, so this is something I do. Why I know this one? Because actually I was in charge of the management of this kind of our UST clean room facility for fabrication of semiconductor MEMS or biochip. So that we have 3 machines. Now we both from Germany, from UK. Unfortunately, engineer cannot come to Hong Kong to do installation. So that in this case, can we use VR AR headset to solve the problem? What do you think? Can we? Let me show you this kind of HoloLens too.
What if there was a way for employees to work together from anywhere when everything is on the line? Employees are the heart of every business. It's their resourcefulness, ingenuity, and drive that get the job done. But even the best employees need help from people who aren't there with them. Now employees on site can work side by side with experts in remote locations. In an instant, they can share what they see, lend a helping hand, walk through the process step by step, helping solve problems in real time. This is a new vision for work. Now employees can work smarter and bring in the people they need with just a tap. They can troubleshoot, repair, and perform with confidence and speed. They can move freely, pull critical information into view, and stay focused on the task. Their hands free to do the work. This is collaborative problem solving at full speed. Your people, united across time and distance, more connected, more informed, and more efficient. Now employees can work together from anywhere. They can go there without being there. This isn't the future. This is here and now.
So actually, I do recommend our UST, this clean room facility, to think about use this kind of HoloLens to solve our own problem. We bought 3 machines for fabrication of this kind of a microfabrication. But you see, engineer cannot come to Hong Kong to do installation. So actually this have been used in real scenario. For example, those ASML most advanced stepper from Netherlands, so that when they ship this kind of extreme UV stepper to TSMC, to Samsung, to Intel, so that they really use this kind of HoloLens to install this kind of stepper. Doing that is become COVID-19 make a big problem, so that in this case, this kind of big international company really try to use this kind of system to solve the problem. Doing that. So this is something I just tell you, unfortunately, COVID-19 create big trouble, so that how we can solve the problem with this kind of VR, AR headset. So this is something is, of course, this ASML, one machine to make a 5 or 3 nanometer chip. Do you know how much? Any idea? Most advanced this kind of extreme UV lithography to make your iPhone's processor for 5 nanometer or 3 nanometer. How much is that machine? Any idea? About 100 million or 150 million US dollar for one machine. So that this is something is as I show you, it's non-trivial. So that engineer have to use this kind of thing, this kind of HoloLens to install this so expensive machine in remote way. So this is something COVID-19 make big.
ASML is a critical supplier of semiconductor lithography.
This is a 150 million machine, and this company in Netherlands also have to use HoloLens too to do installation of this so expensive machine. So that's something is, I tell you, COVID-19 big trouble, and then so that this become very important technology to solve the problem. yeah. And of course, I will mention that there's a series of this kind of low-end to high-end VR assets. So that again, so that I recommend you, if you can chance to go to Hong Kong, this kind of science museum, and actually they have this kind of interesting VR system, cave. So that it's something interesting for you to visit. Again, is you don't need to buy this thing, right? There's a Hong Kong government do have this kind of put this kind of cave in science museum, and of course, this kind of cave have been used for a series of I think for demonstration of technology, or for this kind of you see museum application. Right? I'm pretty sure also important, useful for education. Yeah, and of course there's a series of these things, right? Cave, this kind of virtual reality system can be useful for this kind of education, or for this kind of demonstration of new technology. And of course, one student also mentioned, definitely this can be also useful for this kind of new type of 3D learning. One student mentioned, so that in the future, can we don't use Zoom? Can we use VR, AR, MR for this kind of online teaching, has more interaction? What do you think? Can we try this kind of VR, AR for this kind of online teaching? What do you think? Of course, that require over you to have VR system. That need money. But anyway, so I think this is if this become more and more mature, right? So be much cheaper, a lot more, and then so that when all the new technology in launch, so that in the beginning expensive, gradually you have a cheaper, so that in the near future, hopefully, this kind of thing can be really used for this kind of 3D online teaching. I do think hopefully in the future, this kind of HoloLens will be much cheaper. Do you know how much is the HoloLens 2 in Hong Kong? Any idea how much? It's about 30,000 Hong Kong dollar. Oh, it's quite expensive. Okay, it's quite expensive, so that I don't believe it can be useful for our online teaching. But it will be hopefully in the near future, right? It's something I do think it will be quite important. Maybe we should request our UST to buy for some of selected students for this kind of online teaching, right? So that is something. I do think it would be useful. Of course, for medical teaching, that is something I do think this is one of quite important application for medical education. So that you see, if you have this HoloLens 2, those kind of medical doctor, the student in medical school, they can try to see this thing.
The HoloLens is absolutely the most amazing piece of technology.
HoloLens.
Within 5 seconds, I realized that the world had changed. It was an immediate realization that this is something exciting and we have to be a part of this. Seeing things in 3D is something that you could do before with some glasses. The thing that the HoloLens gives you is the ability to walk around those 3D objects and to really experience them as if they're in the room with you.
It is augmented reality, it is mixed reality. And what that means is I still see you, I still see this room and everything around me, but the digital content is inserted into the room as if it's actually there.
As a teacher, I can see what they're all looking at. And that's something that we think has real power.
It's actually opening up our interactions with each other.
The biggest drive is getting the anatomy curriculum completely done by the time we move into the new health education campus.
Today, we and the Cleveland Clinic are constructing a state-of-the-future health education campus. Our students will learn using the most forward-looking educational programs. HoloLens is a key part of this.
The actual act of dissection hasn't changed in generations. We have to be much, much more effective and efficient.
The biggest thing about medical school is there's just so much information and so much knowledge you're being asked to learn.
HoloLens is going to enable us to teach in an integrated way and to look at the body in ways they haven't been able to see it. It's sort of having X-ray vision, seeing through the skin.
My mind was just kind of blown. When I tried it on, it was perfect. It's really hard to understand what the anatomy and book's trying to tell you. So with the HoloLens, we can literally show you what's happening with the body.
We can look at how the heart moves, or look at how the brain processes information and how information flows around in our brain.
They can see when the heart valves are closing and hear the sounds.
How the diaphragm moves, when the lungs move. A click of the fingers is going to allow students to see how everything's interconnected in the body.
We have means to draw people's attention to things to get them where they need to look. Do you want to look and then pull the bones out?
And what they really crave is learning anatomy in the context of what they need to know clinically. What are they going to need to know for their clerkships and their future careers?
With HoloLens, we can have essentially any disease that you want to see.
So when I see an image like this in the hospital, I know exactly what's going on. This is how to treat and diagnose them.
The HoloLens provides like a new way of teaching anatomy. It can really speed up the process of learning this material.
I think HoloLens is the next big transformative change in medical education.
So I do think this is something will have the impact on many different kinds of education, not only medical, but even for this course, we look at the kind of how we can use this kind of VR, AR, MR for this kind of building engineering or automotive engineering. So many engineering, I do believe will be very important and useful to really enable our students to have this kind of experience, thing, right, in this kind of virtual reality, VR, AR, MR. So that's something is you're right. So our UST have no medical school, so that unfortunately that doesn't. But I just show this is one example. Why definitely medical school is something neat you can see, but same HoloLens is not only useful this kind of thing as I mentioned, right? So in our previous slide, we show you about that Cadillac Studio has this kind of a system for building engineering, right? I just show you. Actually, you can. Of course, one student, Truman, mentioned that for sure, this kind of VR, AR, MR can be quite important to train some pilot, and that is some critical, right? So things before the pilot get the license to fly the real airplane, so that if you try to use this kind of thing, that is something will be very important for this kind of professional training about this thing. So I do think this all this will be very important, right? So that you can see this kind of things can be also useful for demonstration of new technology. Caterpillar is a big company in the United States to make a truck, so that they do have this kind of thing to show some kind of new technology for this demonstration, right? And I just now once you mention pilot, so that you can see, so that for sure, this kind of VR AR can be useful for training not only this kind of pilot, and so that this is something for sure is one of important thing, like helping youth in this kind of aerospace engineering. That's something there's no doubt at all, right? And but of course, can this one be really useful some low end the engineering training? So that's something I do think is also important. And you see, this is give you example, right? So that the people really use the Boeing have this kind of I do believe it's quite expensive simulator system with this kind of Facebook VR, so that actually I do think there's this kind of a game, this kind of video game to simulate this kind of flight, flight simulator, right? So that definitely this is very expensive. This kind of Boeing, this kind of thing is very expensive, but with the advanced consumer grade like Facebook VR system or HoloLens, Microsoft HoloLens, so that you can before like a whole pilot need to use expensive this system, but now with this kind of consumer grade system, all of you can play now. So that's something I think is quite important. Okay, there's another branch of this kind of thing, haptic feedback. You see, for this kind of our visual audio, right? A typical VR AR system, but another thing, how you can play your finger or your hand can have more realistic this kind of experience to touch. For example, I want to really try to have simulate this kind of I'm driving this kind of airplane. So that in this case, we need to produce this kind of haptic feedback, right? To let this kind of people to have real experience. Okay, I'm playing the joystick of the real airplane. So that in this case, you see, haptic feedback is something quite important, right? So typically, there are two types of this thing. One is touch, feedback, okay, and another force feedback. Force feedback, in this case, they can actively resist the contact and then feel, and then so that this is something will be quite important. You see, that in this case, what's important to achieve this kind of haptic feedback? You need to have MEMS actuator, not only sensor, so that to have produce this kind of experience. So you see, typically you have active this kind of haptic, okay, using this kind of glove, and this kind of this kind of thing is, I think it's a very mature this kind of active haptic system in the old day. But of course, you see we have a lot more sophisticated this kind of system, like now this is an important thing, and then Fenton is thing for enhance this kind of a user human machine interface, right? for us to maybe for engineer to do a design with not only mouse and keyboard, right? So that's something. Of course, like Apple also what Apple Pencil. I think that's another thing, right? So the Apple Pencil has a also very sophisticated kind of sensor. So for you to pricing, this is quite important. And then of course, there's another thing, haptic glove, right? So this is something you see, yeah, very sophisticated. This kind of you see, this glove have 133 tactile actuator, okay, and 30 check the degree of freedom thing to look at this kind of let you to experience this kind of experience about thing. Do you say it's quite important for all of you to understand this importance, how we can more make this kind of more realistic this kind of experience. HTC Vive VR, as said, with this kind of haptic feedback. Degree of freedom, this kind of really sensing. Okay, so this give you some ideas so that so beyond a visual audio, so there's another important thing for this kind of more sophisticated interaction, this kind of touch sensation, right? Is this kind of haptic sensation. Of course, we have an active one or passive one. Passive haptic is typically, for example, keyboard and trackball and mouse, right? This is something is a passive, okay? And then, of course, again, we have also a series of this kind of passive, this kind of haptic device for a human-computer interface, right? So that's something I should tell. And then again, so that actually there's a series of this kind of haptic feedback or tactile feedback for you to think, so that typically you can think about this using the air bellow, jet, actuator, micropin, electrical, and neuromuscular stimulation. So this is something, of course. One more is I will mention actuator here. We may just show you one more. Most likely it's a piezoelectric, right? Actuator, so that you can generate kind of ultrasonic kind of wave, so that in this case we can touch, can feel something more realistic. So that is something important. I know that people really try to make this kind of more simple and more realistic, this kind of haptic feedback or tactile this feedback for VR, AR, and MR systems. So this is something I think quite important. Yeah. And of course, another thing is a vibro tactile cooling device. I believe every smartphone have this kind of little gadget here, very tiny motor, right? So that as for example, this kind of vibration mode in your smartphone, right? But of course, for new type of this kind of thing, vibro tactile device, so that actually you have a more sophisticated. For example, in iPhone has a much more sophisticated, not only motor. So here I show you this thing. You see, new iPhone have this kind of they call taptic engine. You have some small motor, but additional this kind of coil and this thing actuator. So that this is something Apple actually put a lot of money to do much more sophisticated this kind of haptic feedback for their iPhone. I just tell you, this is something I believe once iPhone have this kind of haptic feedback, and many other smartphone or many other company making VR, AR, MR will be thinking about how to implement this kind of more high-end, this kind of haptic, this kind of feedback. Okay, so that so this is something quite important. Of course, one more this kind of thing is not only use consumer like this kind of device, smartphone, but also for using maybe aerospace engineering or some gaming, right? For example, this guy is made by because Navy's the kind of the system they call tactile situation awareness system, so that for aerospace engineering. So basically, they want to measure the decrease of this controlling tilting. Okay, so it is a tilting issue, so that on the astronaut after short-term space flight, so that for aerospace engineering, probably for also for gaming. If you go to the sandbox, as I told you, now we gradually Hong Kong government really reduce this kind of thing, social distance. Hopefully, some of you are able to go to this kind of sandbox or somehow VR, AR, those are gaming, this kind of company in Hong Kong to play. I know that, I don't know if you sandbox Hong Kong for this kind of game. So actually, we do have this kind of Hong Kong sandbox, this kind of VR, AR, so that you gaming, so that you can find interesting that company and in Tsim Sha Tsui. Okay, so that you can try to play maybe with your friend about this kind of VR in this Hong Kong, this kind of company provide. You can try to look at this kind of interesting gaming with a VR headset, so that do have a company. I think this company is doing the good job, got a big funding, not only have this kind of office, provide the gaming, VR gaming in Hong Kong, being made in many other cities, not internationally seeing, so that it's quite interesting for all of you to think about the near future, right? So I definitely this VR, AR, MR will be continue to improve, and then the thing, right? And as I told you, I will mention this kind of haptic feedback glove is something important for professional gaming, right? And then, and of course, this VR system, STC by basically, as I mentioned, they have a very sophisticated, this kind of more than 70 sensor, right? And then including 37 photo sensor in VR headset, and also MEMS, motion sensor, IMU, and additional things. So it's a very complicated this kind of VR system, and also very expensive. I think this is also quite very expensive. And of course, we'll mention that VR, AR will be quite important for medical training or real surgery. So that I do believe this is another quite important. And it happened, one UK medical surgery company, they actually also have a branch in Hong Kong. So that this company received 600 million US dollar, and then to develop this kind of surgical robot, right? Of course, Da Vinci is one very mature surgical robot, got US FDA approval in, and do remember Hong Kong U, CHK, the medical school and hospital, they do have this kind of machine for the kind of minimal invasive display, minimal invasive this kind of surgery. Okay, so that Anyway, so there's I would mention there's a we also mentioned HoloLens. It's a quite big project of Microsoft, and not only for you can see for this kind of consumer application, right? As I show you, for real industry in the COVID-19, I think HoloLens become very important for industry, so that it's a very sophisticated VR system, and then with a very sophisticated kind of a optical system. Okay, so that we unfortunately we almost run out of time. So again, so today we give you this kind of understanding about a lot more detail about VR, AR, and MR systems. So that I don't know, do you have any question? And of course, again, I don't mind. So that we do know that some students interested to play my this kind of Facebook VR system. So that I don't know if we can try to fix some particular time slots, so that for some of you want to play. Like I know that through this kind of Facebook, to this one, it seems at least 7 students interesting to play this kind of thing. Again, it's free of charge. But I do think it's beside you just attend our lecture, if you really experiencing, it's a very, very good experience, right? So that we can try to fix a particular time slot, and then maybe I should also ask TA to help this kind of arrangement. So it's actual this kind of session for some students if they have never tried to play with this kind of more professional VR headset. So that I asked one student say, yeah, right. So unfortunately, I think we have actually I try my best to make sure we can try to finish all the lecture, but of course we try the best to finish everything. But if we don't have enough time, so that I will try to make sure that to cover most important content, right, for this course, right, so that of course there always a lot more topic, right, so that I do believe VR, AR, MR is very critical for this kind of technology, especially at this moment. Okay, anyway, so that I will ask TA to help to maybe if for some of you want to play VR, so that there's no problem. We can ask TA to arrange and thing.